Welcome to our session today for Grade 10 Maths Literacy. We're going to be looking at the section on plans and models today. And this section really involves a whole variety of mathematics. It brings together many of the sections that you've dealt with up to now and puts them together for some practical application problems. So let's go straight to our slides here and see what we have. First of all, we're going to look at some types of plans that you may encounter in the questions that you will face in your exams. Now, really, there can be so many different types that I can only give you a selection of the types you might see in the exam, and certainly won't be able to cover every eventuality that you will have to deal with. Then we'll look at some key features, things that you will need to look at or look out for when you look at a plan so that you can answer the questions that are asked of you. And lastly, we will look at using models to solve some problems of a practical nature. We'll get to those in a moment. Now, plans are useful in providing information about the environment that we live in. And they are useful for simplifying a complicated situation. So let's just fill that in over here, because we want to simplify things in our world so that people can understand what they are dealing with. And we use plans in many different circumstances to make sense of our world. Some examples that you may have already encountered are a floor plan for a building. Certainly if you go along to a shopping center and you are looking for a certain kind of shop, you will have probably encountered a board which has a floor plan of that shopping center, and it helps you to understand where you are and where you need to get to. Then you may have already seen a seating plan, for example, for a theatre or for an aircraft. You know, when you step onto that plane and you're looking for where you need to go and sit, they'll usually have a map or a plan showing you where you need to go in order to find your seat or the number of your seat. Then there's a fire plan to show key routes in the case of an emergency. These are a necessity in most buildings today, especially if that building is large and has many internal corridors. It is vital that you have a floor plan showing you the nearest exits in the event of an emergency. And lastly, we have a plan of maybe how to assemble something. Perhaps you've bought maybe a model aircraft or something of that nature, and you need to put it together, or you've just got a new computer and comes with many parts and you need to assemble those parts. Then you will get a plan in the box showing you how to do that and how to put the whole thing together. A layout plan is another option, and for example, say you go to a rather large area like a campsite or maybe a game reserve. At the entrance where you pay for your ticket or you do your booking, they will usually have a layout plan of the site or the game reserve, giving you the key areas that you can go and visit to go and see different types of animals, or if it's a campsite, for example, where you can camp, where there's a watering hole, where there's ablutions. All kinds of information might appear on a layout plan of that nature. Now, although these plans are all very different and deal with different situations, many of them have very similar features on them. And there are some key things that we can look out for when we are approached with a question that deals with a plan of these natures. So let's have a look at some of the key elements that you will encounter when you are dealing with floor plans or the like. There are some important features that need to be noted when we look at a plan. And the first one is look out for a key. Now, a key is usually situated in the top left or the bottom right or somewhere on the plan, usually in the corners out of the way. But what it does is it'll give you maybe some symbols or some signs that will help you understand what is on the map. For example, if you had an ablution block on a campsite, you wouldn't want to go and label it with the word ablution. That's a very long word, and maybe there's not space on the plan for that. And so often they might just use a symbol of a male and a female toilet sign, and you should know that that then represents an ablution block. Or if you had, for example, a place where, in a game reserve, there was a place where you knew that the lions usually lived or congregated, then they might just simply put a picture of the animals, or maybe just a different type of animal would be on the key, and you just say, okay, there's animal sites, and then on the actual map, you'd see, there's a sign of an animal. That means there's animals or places where we can view the different game. So a key is an important part of a plan. Next, look out for any directional pointers, a compass, for example, something that points out north, south, east, or west. And in our previous session, we actually dealt with looking at maps and compass readings, so we won't do all of that again today. But compass readings or compass signs are usually a common feature of maps or plans. Then there may be some kind of a numbering system. This is important, for example, if you're looking at, again, theatre seats, and we'll look at an example with this later, or aeroplanes where you have plane seating. The numbers are important. You need to know things like, there's row 5, or there's seat number 17. And then you need to see whereabouts those are. Which side of the theatre does the numbering start from? And that's an important feature of a certain plan. Then note any important objects or landmarks. For example, again, let's say if we return to maybe the game reserve plan, it might be important to find where there's a rest stop, or how far away that rest stop is, a cafe or a place where we can get out of our car and have a rest or buy some refreshments. You'd want to find those on the map so that you know that you're heading towards those places in a reasonable amount of time while you're driving through the game reserve. And then lastly, just look out for any other important symbols which may appear on the plan that you have in front of you. All of these, as I said, are pretty common features, and they're important that you make note of them. So when you face that question in the exam, take a few moments just to look at the plan and familiarize yourself with what is on the plan. If there's symbols that you don't understand, try and see, can I look on the key? Is there a label for that symbol? And that will help you to make sense and prepare yourself for the questions that will follow in time to come. Now, here's a nice little example, and we're going to take a look. This is an example of a seating plan. Let's get it into the screen here. And this is a theatre. As you can see here, we have a couple of labels. I'm going to just explain them quickly to you. Right at the very top, we have the word balcony, and then in the middle here, we have a word mezzanine, and then we have center orchestra, and on the left-hand side here, it says side orchestra, and it says house right, and then on the right-hand side of our screen, it says side orchestra, house left. Also, on this diagram or this plan, you can see there are some squares which have different letters for the different rows. For example, over around here, you have the letter D and then E going all the way up to J. In the mezzanine, you have the letters A, B, and C. And then there are some numbers from 101 to 106, 111, 118, running across the rows right up to 126. So as you look at this, you need to say, well, let me see what we've got there. There's also some other words. For example, here in the mezzanine section, it says wheelchair access. And if we go down a little bit further here, right at the very bottom of our screen, it says center aisle seats are number 102 house right and number 101 house left. Now, all of this is giving a layout to the patron or the person who's coming to visit the theatre so that they can make sense of their tickets that they've received. You see, on their ticket, it may say mezzanine level B105. Now, they know that they've got a seat number allocated to them, but they might not have a clue where to actually go and find that seat. And so the first place they'll go and have a look at is one of these plans to go and see, where am I actually sitting? Well, let's use that example just quickly to just say, where is B, mezzanine level, row B, and seat 105? Well, mezzanine level is over here. This is row B, and this is seat 103 to 107. So if I count across 103, 104, 105, our patron, our imaginary patron, would be sitting over there in this theatre. Now, just if you're not sure what some of these words mean, let me just quickly explain. The word mezzanine is a middle section. And obviously, this theatre is divided into three sections. There's a ground floor known as the orchestra section, and that's because the orchestra are also being seated on that floor. Then there's a middle level known as the mezzanine level, which would probably be upstairs. And then even further up, maybe a further floor, we have that section called the balcony section. So this theatre is divided into three sections. That's what this diagram is explaining to us. Well, there we have a good example of a seating plan. Let's go on and have a look at another example quickly. And we see here we've got a floor plan or a plan of a shopping centre. These are very common if you go to most malls today. All of them will have dotted around the mall, usually at the entrances where you come in, a place where you can see the different shops and how they are arranged in the mall. So having a look at this one, if you can see, I know there's a lot of detail on the screen, but you can see some familiar shops. For example, over here we have the C&A, and on this side here on our left we have Checkers Hyper. There we have a sign for a shop known as Woolworths, and right on the far right-hand side of the screen we have Edgar's. So these are some familiar shops. Other shops you can see don't have actual names here, but they do have numbers. For example, we've got over here L15 to L19, and somewhere maybe on that floor plan you would come with a list of the different shops and the numbers of those shops so you could locate the shop in the mall. The layout of this plan also gives you the actual pathways along which to walk and shows you sort of the directions that you need to follow so that you can make your way around the mall and find those shops that you're interested in visiting. All right, well, let's do a question and just see how some of this would be used in your examinations. So in this section, and we have a rather large picture over here, but we're going to use the following seating plan to answer some questions that follow. What we have here is the seating plan for an aircraft. And you can see there's two pictures here on our left and our right of the aircraft and the layout. I'm just going to scroll down so you can see the bulk of it. And then let's have a look at what the questions are for the seating plan. The first one says, how many seats are there in the upper deck of the aircraft? Well, that means we've got to decide which of the two is the upper deck. Well, that means let's have a quick look and see if there's any labels on this diagram. And if I scroll back up to the top here, you can see it says main deck for the one on the left and upper deck for the one on the right. So the one we're interested in is this one, the upper deck. Now, they've been very kind to us. We don't have to actually go and count all the seats. They've done that for us on the right-hand side of the diagram. And you can see over here, they've said there's 14 seats in this section over here at the top. Then if we go down a little bit further, we've got 58 seats on this middle section over here. And then we've got a further 18 seats situated in this section over here. So that gives us the entire section of this aircraft. So what we'll need to do is to actually add all of those up, because it said how many seats are there in the upper deck altogether. All right? So what did we say? We had 14 plus a further 58. And in the third section, we had a further 18. Make sure when you're looking at diagrams, firstly, that you have answered the question correctly. It's very easy to sometimes confuse, for example, in this question, the two decks. So make sure you're using the correct deck to do the calculation. Also, go back and check, have I done every section that they've asked me for? We want all three of those sections. So we've got the 58 seats, we said, the 14 at the top, and of course the 18. And if we add those all together, and you can use your calculator for this if you're uncertain or just to make sure you're doing it all correctly, let's quickly do that. We've got 14 plus 58 plus a further 18 seats. And we see that the total for this section is 90 seats. So let's just fill that in over here. And there we have 90 seats altogether. Now, the nice thing about these questions is that really all the information is given to you. You just got to make some sense of it in order to answer the questions that you're being given. Let's follow that up quickly with the second question. I'm just going to make a bit more space here. The second question, or part B, reads, how many sets of toilets are there in the upper deck? Now, if you go back to your diagram here, you'll see that actually there hasn't been a label that says toilets anywhere. If I'm looking on my diagram, I don't see the label toilets. But what I do see are some signs that should be familiar to all of us. And you can see they're located in this section over here. I'm just going to circle this quickly so you can have a look. These symbols over here. These are the familiar male and female signs that we're all used to seeing in malls and theaters and the like that represent the toilets for the males and females. So we need to go and look and see how many of these symbols are located on our upper deck. Well, I've got one over here, and I can see another one on this side. There's a third one over here. And if I scroll down a little bit further, we can go down to see right near the bottom here. I think we've got a couple more. Here we go. There's one. There's a further two in the middle here, and another one over there. So altogether, I've got 1, 2, 3, 4, 5 for that one over there, 6, 7. So now we can answer our question. We've seen that we've got 7 sets of symbols. And they did say how many sets of toilets are there in the upper deck. So we're not interested in the number of toilets because notice there's a male and a female for each one. But we've got 7 sets of toilets in this aircraft on the upper deck. So you would simply go and answer 7 sets. Or if you wanted to, 7 sets of male and female toilets. Again, just a caution, when you're answering a question like this, go slowly and look through it carefully. One of the things that you don't want to do is count and say, suddenly I see 6, but you've missed one because you didn't look carefully enough. So the big thing is really to be thorough when you're dealing with the question and making sure you do answer the question correctly by making sure you've noted everything on the diagram. And it is so often, because there's so much information, it's easy to miss just maybe one set like this of the toilets, and then you answer something like a 6 when actually there was one more. So go and check carefully. This is really where you want to make sure you get marks, because all the answers are really on the paper for you, if you're careful enough to note everything. Let's continue our question with our aircraft. And we've got a couple more here. We've just put the diagram on for you again so that you can see what's going on. The question C says, how does the upper deck connect to the lower deck? Now here you'd have to also try and understand what this diagram is trying to show you. And you might say, well, nothing says that here is where we go from upper to lower deck, but what other kinds of symbols do I have on this aircraft? I can see there's some other signs over here, which again, maybe don't look familiar to us immediately, but something that might give you a clue is these symbols over here. If you have a look just at the bottom of our screen, I'm going to circle it for you so you can see. What would that be, or what does that look like to you? Now, again, there's no label here, so you're not too certain, but that looks like a set of stairs. And certainly this would be a place where we would connect the aircraft from the upper to the lower deck. And you can see they're both in the same position, so you would need to write some kind of sentence for this and say, at the bottom of the aircraft are a set of stairs that move from the upper, or set of circular stairs that move from the upper to the lower deck. So I'm just going to write here, set of circular stairs. At the bottom of the aircraft plan. Connect the two decks. When you answer a question that requires some kind of sentence or explanation, also don't just write one or two words, things like stairs at the bottom of the decks, because that's not very clear as to what you're referring to. Always ensure that you use good language and that you write a full sentence so that the examiner who's asking the questions is in no doubt as to what is being referred to. Never leave it in an ambiguous form so that the examiner has to guess what the answer is, because generally he doesn't want to, or he or she doesn't want to guess. They want to be sure that you've understood the question fully and have explained it fully back to them. All right, I think we can take a short break here, go and get yourselves some refreshment, maybe some fresh air, and we'll be back in a moment to continue some of our questions. Welcome back to our Maths Literacy session for grade 10 on plans and models. In our last section, we were busy dealing with a question on aircraft, and we were looking at an aircraft model or plan, a seating plan of the arrangement of the seats on the aircraft, and we're going to continue with that right now. So section D, or question D, asks us to explain using the diagram how the classes of air tickets for economy, business and first class are arranged in the aircraft. So for this question, we have three different classes of seating arrangement. I'm sure you're familiar with the fact that on aircrafts they have different seatings for different classes of passengers, and they charge different prices for the tickets. And here we have economy, business and first class. So what you're looking for on the aircraft is three different arrangements of seats. Well, let's have a look at what we have on our drawing. Remember, we had the two decks. We can see we've got a whole section of blue seats here, or green, depending on what color it looks like on your screen. And then on this side, we've got a yellow color of seating over there. And then we've got up at the top here, we can see some turquoise seating. And you've got to make a decision now, because there's no labels on this diagram, just the different seats. You've got to make a decision as to what arrangement of seats has been given in terms of the different classes. Now, how will we do that? Well, if I look at the main deck, I can see I've got 76 seats here, 135 seats here, and then 188 seats here. For this bottom section. On the top section of the deck, we've got 18 seats. We counted these earlier, if you remember. 58 in this section, and then we've got 14 seats over here. Well, how would you decide as to which seats belong to economy, business, or first class? Well, the obvious answer, hopefully, is that the seats or the places where there are the most seats would belong to the people who can pay the cheapest price, because more people would want to pay a cheaper price for their air tickets, and only there'd be a limited number of seats, for example, for the business class, and maybe even more limited for first class, because those seats are usually very expensive on a plane. So this is something that the examiner would expect you to understand or to know about, and so a bit of general knowledge here is what is actually required. And what you would then say is that, okay, because there are so many seats in this bottom section or the main deck, this is probably belonging to the economy class. So when you're answering the question, go and make a note of the three types, list them: economy, business, and first class. And then as you list those, then go and say where these are located. Main deck. And since all the seating in the main deck is of the same type, and you can see all the seats here, they're all the same type of seat. There's no differences here. You can leave it at that. The main deck is for the economy section of the aircraft. But on the upper deck, we can see we've got two different types of seating. We've got these yellow seats over here, which are located near each other, and then these quite sort of large cubicles, of which there are only 14 right in the front of the aircraft there. And you need to decide whether you think these yellow seats are for business or for first class, or whether it is the blue ones that are for the business or first class. And again, based on pricing, because business would be more expensive than economy, but not quite as expensive as first class, I would suggest that we're looking at business class here, these 58 seats plus the 18 seats at the back of the aircraft here. Those would belong to the business class. So let's make a note of those on our answer. And we'd say here business class, upper deck, and also make a note that it is the yellow seating. Because we have two different types of seating on the upper deck, we need to distinguish between the two seats. Well, that leaves us lastly then with the first class, and we can see that first class belongs to also upper deck and blue or turquoise seating. If you wanted to, you could possibly say something like the 14 seats in the front of the aircraft, or for the business class, the 58 plus 18, which comes to 76, the 76 seats on the upper deck that are yellow, if you wanted to be more specific than that. But I think our answer here gives a nice clear description of the different types of seating and where they are arranged. Again, if you were unsure, remember, or try and remember now, that economy seating is cheaper than business class, and business class is cheaper than first class in an aircraft. Again, that's just something from a general knowledge perspective that you would be expected to understand. But hopefully now that you've seen this type of example, you'll be able to answer questions into the future that might relate to a similar diagram. And then lastly on this question, we have a question that says, how many exits are there altogether for this aircraft? Well, again, let's go and look at our picture. Everything refers back to the diagram. And we're now looking at places where the aircraft has exit points. Now, again, you might be unsure because we haven't seen any key on this diagram, but we look at these arrows that are given here. And arrows generally point to a direction, and we can see these are pointing outside from the aircraft. So it would be a good thing to assume that these are the exit points for our aircraft. if we look at them then, simply what we have to do is count the number of exits here, and then we can answer the question. So let's start. We've got 1, 2, 3, 4, 5, 6 already on this part of our diagram, and moving down a little bit further, we can see we've got over here 7, 8, and I'm going to go down a little bit more, 9, 10, 11, 12, 13, 14, 15, 16 exits. So let's go and fill that on with our answer, and we know we've completed the questions. So total there are 16 exits. Let's just erase that quickly. And 16 exits on our aircraft. Again, it's simply a matter of counting, but go slowly and do it once or twice at least, not just once, because if you look at it twice, then you're guaranteed hopefully to answer it correctly, and make sure that you don't just miss an exit or something like that. I would even say to you, take up your pen or your pencil that you're busy using and cross them off as you've counted them, so that you get an accurate answer. The questions are not so difficult to answer in this regard, but it can be easy to just miss out on something and then put the wrong number down. And of course, if the examiner sees the wrong number, he's not going to give you the mark. Even though you knew what to do, you haven't been careful enough to do it accurately. So please be careful and make sure you are accurate in your answers. Let's move on to another question now. So here we have question 2. And this question is based on our floor plan for our mall. You saw this one earlier, and we're going to use this floor plan to answer a number of questions. It says here, using the floor plan of the mall, answer the questions that follow. So let's go and have a look at what questions we have here. The first one says, what is the store number of the C&A? Well, to answer this question, you've got to go and locate the C&A, which is not too difficult to do, because if you have a look on our floor plan here, you can see it is nicely labeled for us, quite a big store in this mall. And the interesting, or the place that we look at, what we're interested in, is the number L51. You can see it just above the store there. And all through this diagram, you can see there are many store numbers. They've labeled them with a letter and then a number. And all you have to go and do is then write that answer on your sheet. So let's do that. And we're going to write L51 for the C&A store. Right, then it says, how do you know that the Stutterfords is a multi-level shop? Well, again, you'll have to go and locate that store, and if you have a look here on our diagram, if we're looking through, we can see, there we go, Stutterfords is located over here, just next to our C&A. Can you see it? Now the question asks, how do we know this is a multi-level store? In other words, a store that is not simply located on this floor, but also maybe on the floor above or below this diagram. And that would require you to interpret a symbol that you might see on this map. Well, the symbol that I'm actually interested in is this one over here. Can you see it? There's actually a couple of them on this floor plan. I'm going to show you a couple of others. Here's one over here. Here's one over here. And there's a couple over there. Now you might say, well, what is that symbol? What is it indicating? Well, again, you'd have to make some kind of interpretation here, because there's no key given to you. And you might say, what does it look like? And hopefully, because you're familiar with malls, and usually these questions are given to you because you are familiar with certain situations. We all live in big cities. We've all been to malls. You would make the interpretation here that that looks like a set of stairs or perhaps an escalator. And that's what the examiner is actually asking you to do, is interpret the symbols. And although we can see a number of these escalators located on the pathways of this mall, you can see this shop actually has a set of stairs or an escalator in the mall. and it's indicating to you, or in the shop should I say, and it's indicating to you that inside this shop is an escalator perhaps going up to another floor, down to another floor, which means that this shop is not simply located on this floor only, it has a connection to the floor above or below. So to answer the question, you would have to go and write a sentence to say, there is an escalator or stairs located in the store or inside the store. Right. Well, question C, that was simple enough. So question C says, which shop has the greatest floor space? Well, if we're looking, we don't have any measurements for these shops. You can see there's no scale or given measurements. So you can't say, well, this shop is given as 86 square meters, or that shop is 40 square meters, or this one's 150 square meters. None of that is given on the map. But we can safely assume that the diagram of the map is given on a scale basis. So if a shop looks bigger on the map, then it must be bigger in the actual store. That's a fair assumption for this floor plan. So the only thing to do is to go and say, well, which shop is noticeably bigger or bigger in area according to the diagram? Now, because you don't have measurements, it would be really unfair if there were a couple of shops that looked very similar in terms of floor size, and you'd have to now go and measure and work out. That's not what this question's asking. They don't want you to go and say, okay, let's measure this floor, and see which one is bigger. And you don't have to go and measure every floor to do that. The question is simply saying, if you look at the diagram, can you just almost instantaneously see, this shop looks to be the biggest in the center? Well, if I'm looking at this map and this floor plan, I would say that this shop on our left-hand side here, I'm going to circle it for you, definitely seems to have the biggest floor area. It seems much larger than anything else on our map. So that would be a fair assumption to make, that it is the biggest store. And they've also given us a label for this store, the name here. We can see it says Checkers Hyper. So I'm going to very confidently answer that question and say the shop with the greatest floor space is Checkers Hyper. Now moving on to question D, the question says, give directions from the Woolworths entrance on how to get to the C&A. And these are also some quite typical questions that you sometimes encounter in the examinations. They'll ask you to give directions from a map or a floor plan or maybe a site plan. How do I get from point A to point B? Well, what I always like to do when I have questions like that is you've obviously got to go and locate your beginning and your end points. Let me erase some of the other circles I've made here so that we can make some new circles. So we want to get from Woolworths, which is located here at this side. This is the Woolworths sign, and I'm just going to mark it here for you. Let's just do it in green. This is Woolworths over here, and we want to get to the C&A. Now, I can't simply go and do this. Why not? Well, the reason is that's not a place where I can walk. The shop is located here. This is an outside area. There may not be entrances and exits. So we can't just walk across and say we're just going to walk across from Woolworths to C&A. That's not going to help the person who's located in the mall to get from one point to the other. But what we do have is we have the entrance around here. This is the entrance to the shop. Over here, and you can see these blue paths and these yellow paths are the floor plans or the floor walk spaces where you can walk in the mall. They are the passages and the corridors from the outside of the shops. So if Woolworths is over here and we're going to walk all the way along the blue paths and maybe then go along to the yellow paths, we'd assume that the entrance would be off a yellow path here to the C&A, so that would be over here somewhere. What we need to do is follow a path that goes something like this. We could follow another path in this example, because if I wanted to go along the blue path, I could go along here and then take a turn here, go around here, and join up here, and then of course along to the C&A. So let's use this now to explain to somebody who's asking this question how we would get from the one store to the next. Now, these kind of questions, I find people write a long paragraph. They write and they write and they write, and the explanation gets more and more long-winded. When you're giving directions, and I'm sure you've probably been in this situation when you've asked somebody for directions, you think, they're giving me this long-winded explanation, but I really just want something simple and easy to understand. So what are the important things that we need to consider when we're giving directions? Make it as easy as possible. Keep it to the bare minimum, but give enough information so that the person isn't confused. All right, so let's start and try and break it down into small sections so that the person who's asking the question will understand. We're starting at the Woolworths entrance or exit. So perhaps you could start with the following. Face away from Woolworths. And then walk straight ahead. Now here we've given an instruction. If we go back to our diagram, we've said we need to face away from Woolworths. That means Woolworths must be behind us, and we're going to walk straight ahead. Okay, and the person can see, well, there's a long passage. He's going to walk straight ahead. I would suggest that you say to the person, walk straight ahead until you get to a large fountain court area. You can see over here, this area over here, there's a nice big fountain sign. If it's not so clear on your television screen, I know these maps have a lot of detail on them, but you'd see this nicely on the page. There's a fountain over here. So face away from Woolworths and walk straight until you get to the fountain court. All right, so let's fill that in. Walk straight ahead to the fountain court. You see, that fountain is actually a nice landmark in this mall. Because it's such a big, visible area, you couldn't really miss it easily. And so the person, when they get there, they go, ah, there we go, that's it. I've hit the fountain court, I know where this is. What do I do after that? Well, after you've got to the fountain court, which way do you want to turn? Left or right? Well, according to this map, if we want to get to C&A, we need to walk right. And so we're going to go right. So we'll say to the person next, turn right. What other landmarks could we then use for this person to help them get to where they want to go? They'd turn right, they'd follow the path. I would say to them, look here, we've got 2 escalators over here, and also there's a set of lifts over there. Stay on the path, okay, and pass 2 sets of escalators. So if they're walking along, they go, ah, here's escalator number 1. Okay, I must pass that. Then I get, there's escalator number 2, and these are situated right in the middle of the path, so you can't miss them as you're going along. So we'd say, pass 2 sets of escalators. All right, so turn right, follow the path past 2 sets of, just going to continue here, of escalators. Well, after the person gets now past the second set of escalators, they might say, well, now where's the C and A? And you would say, well, surely you can just see it. But maybe they can't. So then say to them where they need to look. Just after the second set, the C and A shop will be on your right-hand side. And then they're going, okay, I've walked past the escalator. I'm going to now look to my right. Ah, there it is. I can see it. Now I've got the C and A. All right, so tell them, don't leave anything to chance as you're answering the question. Let me just erase here quickly so we can just fill the last bit in. And we'll say, right, just past the second escalator, look to your right. C and A is on the right. Now you've given a very clear set of instructions to the person so that they can follow the path accurately. Remember, directions such as go forward, perhaps you can give a distance if a distance is given, or you can say you're going to pass the following landmarks, or you can say look to your right or to your left, or walk right or left. One of the important things to do is to make sure you almost walk the path for the person on that map. And be careful when you're using things like left and right. It's very easy to sometimes confuse those. I've seen many exam answers where the person thought they were walking left or needed to go left, and actually they needed to move right. Just if we go back to our diagram, for example, you see, if I was walking along this path, and if you can follow with my pen here, I'm going up to the top here, then I'm turning right. Now I'm facing this way. And notice again, I'm turning right to go into the C and A. Imagine if I was going all the way to the end of this path. So let's go all the way now. And then I said turn right, and we're going down. And I actually wanted them to turn right again. Would they go that way or this way? So that way or this way. Remember, they're now facing downwards. So their right would be towards these bathrooms over here. So imagine if you were giving a direction to that bathroom, you'd have to say turn right again. And many people would think, because I'm facing forward and I'm looking at this map from this way, it would be left. But remember, the person who's walking in that mall is actually facing us now. They're not facing with their back towards us, they're facing us. And so their right would be back this way. So it's important to keep a good check on how you give directions, which way you're facing as you're walking along the path. And things with left and right are easy to confuse when you're giving directions. So please, again, be very careful that you give accurate directions. I would even suggest, as you're answering these kinds of questions, that you actually label and give a number 1, then a 2, and a 3 as you're labeling the different points of your directions. As you're saying, okay, walk straight for X number of meters, or walk straight until you see the following. That's number 1. Then number 2, turn right over here and walk until you see the following. Then number 3, look to the left and see what you have there, walk to the left. So label them with numbers. That way, again, you're giving a nice logical progression of how the person needs to follow their directions. All right, so then we've got another question here. There's a couple more for this section. What do the squares with figures of people in them indicate? Now, let's go back to our map, and you can see, let's just erase a couple of things here so that we give ourselves some more space, because there's so many lines on here now. I'm just going to clear all this away. You can see we have some signs or symbols again that they're asking us to interpret. The ones we're interested in are these over here. Again, if they're not so clear on your screen, I'm just going to circle them for you here. But what you've got is literally a square block with a figure of people in it. They look very similar to the toilet signs that we've already seen. There's another one over there. Here's another one over here. So dotted all around the center, we have these little squares with people in them. And they're not the bathroom signs, because we can see there's a bathroom sign, for example, with a male and a female sign again, like we saw on the aircraft earlier. Here's another one of those. So these are different. So the question comes, what do you think they indicate? Well, again, you'd have to, because you understand what a mall looks like or what's in a mall, you'd have to make some assumptions because you've been to malls before. And a fair assumption to make here is that this is a place where people can either gather, so the possibility could be that this might be a place where, in case of an emergency, people could gather. That's an option. A more likely explanation, though, because if you look at this, none of those places, or not all of them, seem to be at exit points. So would an emergency congregation venue be located in the middle of the mall? And I think, again, maybe that's not a good option to go for, simply because we see these places in the middle of the mall as well. So then what? Well, actually what they are elevators, transporting people from one floor to the next. They're places where people can get inside and move themselves from one level in the shopping center to another. So hopefully you would understand that, again, because you are familiar with malls, and so we'll answer that one simply, they're elevators. And lastly, we've asked the question, well, on this section anyway, what do the blue and yellow areas indicate? And we've already seen those, we've used them. The blue and the yellow are simply the paths in the mall that connect the shops that we can walk along to. So we can walk from one shop to another on the outside of the shops, following the blue and yellow sections. And the blue would be one section of the mall, the yellow would be another section of the mall. That's why they are different colors. So we can simply answer here, pathways of the sections of the mall, or places to walk if you wanted to, places to walk from one store to another. Good, and I think we have one more question on this section, so let's just go to it. Here you can see question 2 again. It's just the same floor plan. There's just one more question here, and this relates a little bit to some of the work we did in one of our previous sessions. It says, using the floor plan, Peter measures the dimensions of Checkers. He finds that the length is 1.5 centimeters long and the breadth is 0.6 centimeters long. Calculate the floor area of the Checkers Hyper in meters squared if the scale of the floor plan is 1:20,000. Now, I'm just going to do this quickly. I'm not going to actually do a whole explanation because we have actually dealt with this topic before. So if you need to go and check that topic out, please do so. But let's see what we have here. Let's quickly just go to our measurements. So we're at 1.5 centimeters. And what we're going to do is multiply that by 20,000 using our scale. And then I'm also going to do the same and say 0.6 centimeters and multiply it by 20,000. I'm doing this in order to get the actual floor measurements in the building. So let's do that. 1.5 times 20,000. We'll use our calculator for this. So here we go, 1.5 times 20,000. And that's 30,000. Let's write that down here. Give ourselves some space. And remember, the units must stay the same, centimeters. And then we've got one of 0.6. Let's multiply that by 20,000. 0.6 times 20,000, and that's 12,000. So we have two floor measurements, one of 30,000 centimeters and the other of 12,000 centimeters. So we're going to convert those to meters because centimeters are such, there's so many here. I mean, 30,000 is a large number. It would be far easier to work with meter units. And how do we do that? Again, just quickly, 30,000 converted into meters will become 300 because we divide by 100. That means we cross off 2 zeros, so we have 300 meters. That would be the length of this floor space here. And then we have 120 meters for the second part because we again divide by 100. And if we then go and calculate the area, because remember area is length times breadth, we can again go and use our calculator and type in 300 multiplied by 120, and then we'll get our answer of 36,000 square meters. Okay, so let's go and fill that in here. 36,000 square meters. Remember, the area units are square meters. So now we've calculated the floor space of our building there. It's 36,000 square meters. That's a rather large shop. You could probably run a good distance along that shop. If you had it, 300 meters is quite a distance. If you think of a 100-meter race, it's 3 lots of those. So this is a rather large shopping area for this store, but there you have it. We've done the calculation using our map scale that was given to us, and hopefully, like I say, if you're unsure of how to do that, please go back and check our previous section on using map scale. All right, let's take another break quickly now, and you can go and get yourself a quick drink or something, and then we'll be back in a moment. Well, it's great to have you back, and we're going to move into the last section of our Plans and Models course today. We're going to move on to using models to solve problems, and when we are faced with a question where a model is useful, it's good that we draw a plan of our model so that we can actually see what we're dealing with. And it will help us analyze the problem and prepare the mathematical approach and to use to solve the problem. So let's take a look at an example straight up. And here we have a store owner is asked to pack juice cartons into boxes. What will the store owner need to consider in solving the problem? Well, can you think of a few things that might be important if the store owner is to solve this issue that he has of packing his juice cartons into boxes? Firstly, he'd need to consider the size or the dimensions of the box. So let's quickly have a look here. We can just take this away. The dimensions of the box. What does the actual box that we're packing the cartons into look like? What size is it? Then we'd need to consider the dimensions of the actual juice cartons. In fact, I'm going to delete this for you. And lastly, we're looking at the arrangement of the cartons in the box. Delete. There we go. So there are 3 things that he would need to consider: the dimensions of the box, the dimensions of the juice carton, and which way we want to actually pack those juice cartons in the box. Do they want to go with the front side of the box facing the front side of the carton, or the other way around, should I say, the front side of the carton facing the box? Or do we want to pack them sideways? Which way will actually be best for fitting those into the box? So let's take an actual example with some numbers. It says here an example: a warehouse manager wants to stack boxes of tinned foods on some shelves. What would the manager need to consider in this stacking process? And again, we've got a few options that we can maybe look at here. Again, the dimensions of the box to be used, the dimensions of the shelving space, the number of boxes that can be stacked on top of each other, and lastly, the weight that the shelving can hold. All of these are considerations when you want to make a plan for solving this problem mathematically. So let's see how we use all of these with an actual example. Here we go. Question 3, it says a warehouse clerk has to pack cylindrical cans, that means cans that are round on the front face, into boxes. The cans have a diameter of 4 centimeters and a height of 6 centimeters. And the boxes measure 66 centimeters by 33 by 13. Okay, so we have a 3-dimensional box with a can that is 4 centimeters in diameter and a height of 6 centimeters. The question then reads, how many cans can be packed into a box using the arrangement above? And look what we've got here as a diagram. We've actually been given a plan of a model. We can pack the cans next to each other. You can see the circular cans packed into the box. Obviously, we'd extend this diagram and pack more cans along so that we could fill these boxes with cans. Well, on the surface of things, it might seem practical to work out the volume that a can holds and then find the volume that a box holds and then divide the volume that we have for one can into the box to find out how many cans we can use. But there's a problem with that solution, and be careful of this, because this is the typical problem that you'll need to actually work on. The problem with that is simply that the can doesn't take up all the volume of the box. There are spaces you can see over here, for example, these blue bits here, in between. So if we simply just took the volume of a can and the volume of a box and divided, we'd find that possibly we'd actually we'd fit more cans than actually we could into the box based on the volume. What we need to consider is the actual dimensions of the box and the can and see how many cans we can pack in one row or one column in the box. So let's break this problem down a little bit and see what we've got here. We've got a box that measures 66, I'm going to fill it in on here for you, 66 by 33. And we know that a can has a diameter of 4 centimeters. That means across the can, and any direction that you're looking at, that is 4 centimeters. Now, assuming that the cans can stack next to each other in this arrangement, simply by lining them up, we can assume that every can is 4 centimeters across, or takes up a space of 4 centimeters. So what we're interested in is seeing how many 4 centimeter units we can fit across in the 66 centimeter box. Well, to work that out, what we need to do, we'll go to our calculator and say we've got 66 centimeters to play with along the length of the box. Each can takes up 4 centimeters of that 66. How many could we pack across the row? And it says 33 over 2, which if we put into decimals is 16.5. Now, does that mean that I can fit and round off and go up to 17 and say, right, we can put 17 cans in this box? And the answer to that is no, we can't do that, because it can only fit 16.5 or 16 and a half cans. Well, we're not going to go with a half a can anyway, so what we need to do is always round down to the nearest whole number, because we cannot fit more than 16.5. So we can't round up, even though that number rounds up to 17 very easily. That box would be too small to fit the 17th can in. So along this box, we can only fit in 16 cans. I'm just going to put that number over here for us in brackets. We can fit 16 cans along the length of the box. By the same process, if we divide the 33 by our 4 centimeters, because the diameter is 4 again, we see that this one says 33 over 4, or 8.25. Again, I need to round down, so I can only fit 8 cans down the width of the box. So let's just put in the number 8. So our box can fit 16 cans in a row and 8 cans down. And if we multiply that, because we can fit 16 for 8 rows, that means 16 times 8, we can see that these boxes will hold 128 cans if they're packed in this arrangement. So I'm just going to fill that in here. We've got 128 cans in the box. Right, well, these are obviously very small cans, so that's quite a lot of cans in the box. But there's one thing we haven't yet considered. Notice that I gave you the measurements of the box as 66 by 33 by 13. So that means we've got a height to this box as well. Now, how high are our cans? Well, the cans are only having a height of 6 centimeters. So the question we'd need to ask is, could we stack another set of cans on the top of our first arrangement that we had of 128 cans? Well, with 6 centimeter height for the cans and having 13 centimeters at our disposal, we can go and check on our calculator. 13 divided by 6 gives us 2.16. That means we can actually fit a second layer on top. We've got 2 sets that we could fit in here. Obviously, again, we're rounding down so that we don't want to go up to a value of 3. So that means I can actually double this arrangement, and I can say I've got 128 on the first layer, but I can have another layer, so we can multiply that by 2, and that answer gives us 256 cans can be packed into a box that is given by those dimensions. All right, well, that's the arrangement for those cans. The second question here, however, says explain whether this is the most economical arrangement. Now you might say, well, surely that's the best way to pack the cans. We've ordered them nicely. They're in nice, neat rows across the box. Could I pack these cans in a different way? And when they use the word economical, what they're saying is there a way that I could save some space and rearrange my cans in a way that will give me more cans in a box? Well, here we're actually relying on some intuitive ideas of seeing how we can arrange things in a box, because this is not the only arrangement that we could use. I'm going to show you quickly what we can do here. And our answer is based on the fact that we have space in between. You can see that if I'm packing my cans here, I've got spaces in between. Could I better utilize that space in my arrangement of my cans? Well, let me show you. Because we've got some space in the box, remember we said we could fit 16 cans, but there was actually space for 16 and a half. That meant there'd be a small gap at the end of the box on the side here, and also on the bottom, because there was a bit of extra space in this box. So we've got a bit of space to play with. What is another arrangement for my cans that I could use? Well, let me suggest one to you, and once you've seen this, I think you'll further understand how you can rearrange things when you work with this kind of problem in the future. I'm going to put a can over here, and again, let's just draw some cans. Let's make a row of cans, just a couple of cans. But instead of packing the next row of cans right next to, I'm going to pack them in the in-between parts. Can you see what I'm doing over here? So the next row of cans is just slightly shifted down so that it fits a little bit more snugly in between the gaps that we have created over here. So literally this can over here has moved a little bit down and fits more into that little space. Now you might say, well, that's just going to save me a little bit of space. But that little bit of space for every can could add up a whole lot more. Let me just show you quickly what could have happened in this arrangement. Perhaps we save maybe a 1/4 of a centimeter. Okay, let's just do that quickly over here. So let's say we save a 1/4 of a centimeter, 0.25 centimeters in the arrangement of the box that we have here. That means in our 16 rows, okay, 15 of them would actually have saved 1/4 of a centimeter. What is 15 times 1/4? Let's have a look. 15 times 0.25 is equal to 3.75. All right, let's assume that because we had that little bit of space extra, that we actually used the 16th row as well, because we can take that into account. 16 times 0.25. There we go, is 4. So literally, by saving that 0.25 centimeters, that quarter of a centimeter, by pushing the one row into the gaps, I can create another 4 centimeters of space over the 16 rows of cans that I had. And that 4 centimeters of space will literally mean, because the diameter of a can was 4 centimeters, I could fit one more row into our box. And because we had that extra little bit of space at the bottom as well, we've got enough space to move our cans down the row. We didn't have to squeeze them into the box in this way. And one more row of cans means, in this arrangement, I can put another 8 cans into the box, plus, of course, that second row on top. So that's 16 more cans. Well, 16 more cans might not seem like a big difference when I've already got 256. But imagine I'm packing 100 boxes like this. 16 times 100 would mean 1,600 extra cans could be packed in the boxes. I would be saving a lot of boxes that way. So can you see how modeling is important in actually achieving the best result for our question? So let's move on lastly to our final question today, and this is question number 4. And again, we have a warehouse manager has to pack boxes that measure the following measurements of our boxes: 30 centimeters by 17 by 10. And he has some shelving space which he has to pack on, and it says the shelves are 3 meters long, they are 95 centimeters wide, and they have a height between the shelves of 1.05. What would be the best way to pack the boxes on the shelf? Well, I'd need to consider each measurement in terms of my length, my breadth, and my height, and which way it would be best to pack this on the shelf. For example, if I used my length of my box here, the 30 centimeters, and I said, well, okay, the shelving is 3 meters long. How many centimeters is 3 meters? Well, it's 3 times 100, which means it's 300. How many lots of 30 centimeters could I pack along 3 meters? Well, that would fit very nicely, because 300 divided by 30 is simply 10. So I could fit 10 lengths of the box, and hopefully the depth and the height of the box would fit. We're not going to consider that at the moment. So 10 would fit along that way. But what if I packed the boxes sideways? In other words, I took not the 30 centimeter length, but the side width, and I packed them this way. That's only 17 centimeters. How many could I fit along the 3 meter section then? Well, let's have a look. That would be 300, this time divided by 17, and that's not a whole number. It would mean I could fit 17 boxes across. I'm going to make a note of that quickly, but there is some space wasted at the end, all right? So 17 boxes, if I did fit 17 boxes across and they measured 30 centimeters, let's see how much space that would take up of the 3 meters. 17 times 30 is 510. That doesn't seem right. Let's try that again. We said we've got 300 centimeters, and we wanted to divide that by 17. So that means we've got 17, yes. And if we take the 17 boxes, sorry, they are 17 centimeters in length, that means we've got 289 centimeters. Well, we had 300 centimeters available, which means we're actually wasting 11 centimeters of the end of that shelf if we pack the boxes at a side angle using the 17 centimeter face. But what if we stack the boxes again with the height as the part, or the 10 centimeters, facing this way? Then we could fit 30 boxes along, because 300 divided by 10 is 30. So depending on which face you look at, you look at how much you actually can fit in. And again, that would fit in all the way exactly. So the only arrangement that wastes space is this one where if I face it sideways with a 17 centimeter face, I'm actually going to lose 11 centimeters of the shelf. But by the same token, maybe the height and the depth of the boxes, how far they go into the shelves, would also waste space. Well, if I took the 17 centimeter side and we looked at, for example, the shelving we said was 95 centimeters wide, or in the depth of it, how many boxes would I face with that side 95 centimeters wide? I would have to take my 95 now, and I'd have to divide that by 17, and that means I could fit 5 boxes only down the depth. So if I used my 30 centimeter side to fit 10 boxes across, I've only got space then for the width for 5 boxes. And the last one would be my height, which is 10 centimeters, and I've only got 1.05 meters for the height. That means I could fit another 10 boxes up if I use that arrangement. So let me quickly look at all of those figures. We said if I put the 30 centimeter side across, I can fit 10 boxes. But that would mean that the depth, the 17 centimeters, would take up 5 boxes. So we multiply that, sorry, let's just erase there. 10 times 5. And that means for the height of the boxes, because they're 10 centimeters in height now, we can only fit up to 1.5 times another 10. So on one shelf, I could fit 10 times 5, which is 50, times another 10, which is 500. But if I took my 17 centimeter face and put it across, and then I put my 30 centimeter face down the width of the shelf, that means I could fit 17 boxes across the length. But 95 centimeters is all I've got available, and I could only fit 3 30 centimeter faces down, which means that's times 3. And then I still got my height of 10 centimeters, which I've got for the shelf space, I've got 1.05 meters. That means I could fit 10 boxes on top of each other. So I times that by 10. Now, this one we said was 500. But look at what happens with the next one. If I change that face, I've got 17 times 3 times 10. And that comes out to 510 boxes. So simply by turning my boxes and not putting the longest side along the front of the shelf, I have the possibility of squeezing in on this shelf another 10 boxes. Now again, 10 boxes may not seem like such a big difference, but if I have warehouse shelving, and maybe there's 100 such shelves, and I could fit an extra 10 boxes simply by turning my boxes this way, that would mean another 100 times 10, I could fit another 1,000 boxes into that warehouse simply by rearranging my shelf space or my box. And you need to go and play with these arrangements to go and see how much shelf space you can actually use. Don't assume that just because it says 30 centimeters, that means I must fit the 30 along the 3 meters, the 17 along the 95 centimeters, and the 10 along the 1.05. It may be better in terms of arrangements to fit the 30 along the 95 centimeters part of the shelf, the 17 along the 3 meters, and the 10 along the 1.05. Why don't you go and try the calculation by perhaps putting the 10 centimeter along the 3 meter, in other words fitting 30 boxes along the shelf, and then maybe using the 17 for the 95, and we know we can put that as 5 boxes, and again the 10 is the height, or even turning the boxes at another way by saying let's put 17 centimeter side going up, and we put the 10 centimeter side of the box along the 95 centimeters of the shelf. Consider every arrangement, because in answering this question you can see which arrangement would then fit better and how many boxes you could eventually fit onto the shelf. Now the question part B said how many boxes can be put on a shelf using your arrangement? Well, In this question, you simply needed to choose an arrangement for your boxes and then work out how many you could put in. So the examiner would have accepted our 500 or our 510 answer. But he may have followed the question up with saying, is this the best arrangement, or could there be another arrangement? And then you'd need to consider a further arrangement for the shelving or for the boxes on the shelving problem. I hope you've understood carefully now how the first option is not always the only option. And when you're looking at plans and models, you do need to maybe consider, especially with the modeling section, what is the best arrangement for the problem that I'm faced with. We've given you two to consider here and two options in each one, and certainly even those don't meet every requirement. There are several options that we could have used in our arrangement of the problem. I'm glad to have had you with us today, and I trust that this has helped you to understand this section. All the best for those exams that are coming up quite soon, and I hope you enjoy the rest of your time.